5.7. There's no homework assignment on 5.7. 5.8 is just all of the real world stuff with your exponential equations. So you have exponential growth and decay. That is the first thing that we're looking at. So that's physical science, things like that. So you have this equation here where a sub 0 is the initial amount. Okay, AT represents amount after time. E is going to be a constant in the equation. And then you have K is the growth constant. If it is positive, if it's negative, it's decaying. T is time. Okay, so this is growth, we're going up. Decay, we're going down. So negative sign in front of the K for that. So an example of this, and I think this is partially worked out for you. You have carbon-14 is a radioactive form of carbon found in all living plants and animals. After a plant or animal dies, the radiocarbon disintegrates. Scientists determine the age of the remains by comparing the amount of carbon-14 present with the amount found in living plants and animals. Okay, so the amount of carbon-14 present after T years, here's the formula. Okay, so you have amount after time, your initial amount, and then your K is going to equal this, ln2 times 1 over 5,700. All right, so if the fossil contains 1/5 of the carbon-14 contained in a contemporary living sample, estimate the age to the nearest 1,000 years. So it's set up for you. It's 1/5 of the initial amount is what it is. So it's decaying over time because it's 1/5, it's getting smaller. So here's how you would set it up. It's 1/5 of a sub 0, the initial amount. The a sub 0s would cancel each other out in this case, like your logarithms. So this is how you'd be set up. So what I would do here to solve this, after I cross out the a sub 0s, is I would take a natural log on both sides of these, cancels this out over here, and then I have natural log of 1/5, which is 0.2, right? Yeah, 0.2. Equals negative natural log 2 times 1 over 5,700 t. And then in that case, all I've got to do is divide all this out to get the t. So on both sides. So this is just putting it in our calculators. So let's see. I am going to go natural log 0.2. I can just do that. There's only one term in the numerator. Now here in the denominator, I'm going to go parentheses, negative ln2, close that, and then open parentheses, 1 divided by 5,700, close parentheses, close the denominator. So 13,200, and we'll just go 35. So 13,235 years is that estimation of how old this is. And we can check it if we want. We can go E to, we're putting it in here, negative natural log 2 times 1 over 5,700 times 13,235. Yeah. And that gives you 0.2, which is, or almost 0.2. Yeah, it would round to 0.2, so 1/5. Okay, I don't know how many of you are going to be science majors, okay, but that would be an application for science. Everyone is going to be dealing with money though, so that's where I like to take a look at these. So another example here, how long will it take $1,000 invested at 6% interest compounding quarterly to grow to $2,700? So this is the same compounding interest formula from the previous problem. So how long to 2,700 would be our amount after time. Our initial amount is $1,000. We're compounding quarterly, so we're using the same formula we had before. We're not using PERT. We're using this one. Okay, so you've got 1 plus 0.06 for the percent. Quarterly is 4 times a year, and time is what I'm solving for. Okay, so if I simplify inside my parentheses, I've got 0.06 divided by 4, and then plus 1 gives me 1.015. Okay, to the 4t. Then I'm going to isolate this exponential expression, so I'm going to divide both sides by 1,000. That should give me 2.7. Okay, now I have unequal bases. Cannot write them as powers of the same base, so I do natural log on both sides. And then on this side, I'm going to bring the 4t to the front. So I'm going to have natural log 2.7 equals 4t, natural log 1.015. And then I'm going to divide out everything that's not the t. Okay, that way they cancel and leave t isolated. And then I put that in my calculator. So I have natural log 2.7 divided by parentheses 4 natural log 1.015, close the log, close the denominator. And that gives me 16.678 years. Okay, again, if I want to plug it in, I can always go here. I would just go to this point here. I would go 1.015 to the 4 times my answer, and then times 4,000. Okay, so it would take me 16.678 years there. And then this next question we have is a periodic interest loan with amortization. So if I give you this one on a test, I will give you the formula for it. These formulas here, this one, and the PERT formula, you got to memorize those. But these are a little more complicated, so I would put this on the test. And in this one also, the I, this little I here equals R over N. I can't remember if I put it on the test or not, though. But just it'll be there. You just have to know how to solve it. So we have a loan of P dollars at interest rate I. Let's see, is amortized N equal periodic payments of R dollars. Blah, blah, blah. Okay, so you purchase a new car for $24,000. After a down payment of $4,000, the balance will be paid off in 36 equal monthly payments at 4.5% interest per year. Find the amount of each payment. How much interest will you pay over the life of the loan? Okay, so we want to plug all this stuff in here. So P is your payments. Yes, P is the payments. No, your payments are R. P is what we got. Okay, sorry. So what is my loan amount here? $20,000. We did a down payment of $4,000, so our loan amount is $20,000. Okay, so this will be $20,000. And then we have under here, we have 1 minus 1 plus I, which is R over N. So my rate is 4.5. So it's going to be 0.045. What is my N? It's a little tricky because it says per year here, but the payments are monthly. So it's 12. Okay, so it's 12 is my N, but then up here is that 36. This should be NT. Okay, that should be a negative. 12 times 3. It didn't actually tell you 3 years. We just 36 payments for 3 years. Sorry. Okay, so that should be an NT right there. And then divided by R over N, so 0.045 over 12. So there's a lot of stuff here. You just have to be careful with your order of operations. So what I'm going to do is I'm going to go inside this here. I'm going to clean this up a little bit. So we're going to have 0.045 divided by 12. So 0.00375 plus 1. So let me rewrite that. So that's going to be 20,000. Okay, over, this is going to be 1 minus 1.00375 to the negative 36 over, that was 0.00375 here. Okay, so let's go ahead and do that. So I'm going to do the exponent. So I've got 1.00375 to the negative 36. And then I'm going to do 1 minus that number. Okay, so I've got this numerator done. Then I'm going to divide by 0.00375. And then I'm going to do 20,000 divided by that number. So it's going to give me 594.94. Okay, so did I do 200? Yeah, I did 20,000. Okay. So if I didn't have any interest at all, that would be my payment, $555.55, right? 36 payments of $20,000. So I'm paying this difference in interest a month of $39.39. Okay, so find the amount of each payment, $594.94. How much interest will you pay over the life of the loan? You could do the $39.39 times the 36 payments, or you can just do the $594.94 times 36, and then subtract that from 20,000. So $1,417.84. Any questions on that? 84 cents. Present value formula. Okay, so we got one more. And then I just want to make a note here, $594.94. We'll look at that later on, if how much money you'd have after 3 years if you invested that instead of paying on a car payment, right? We'll look at that too. Okay, present value. So this is another formula. Again, this one, anything except for those, the periodic interest and then the compounding and continuous interest, I'll put on the test if I give you a problem, I will put the formula on the test, okay? So anything except the 5.3 formulas. So if you have a child and open a college savings account for your child, how much money would you need to deposit today at 5.5% interest, compounding quarterly if you wish to have $100,000 18 years from now? So that would be like a one-time deposit, not monthly deposits for this one. So one-time deposit, and I just want it to sit there and grow. Okay, so all you're doing here is you would find the amount at the end of the loan. 100,000 would be the A. And then you would have 1 plus your rate, 0.055, over N, compounding quarterly, that's 4 times a year, to the negative 4 times 18. That's going to give you that present value. So again, you can just do a lot of this in your calculator. So 0.055 divided by 4, then add that to 1, and then raise that to the negative 4 times 18, which is 72. and then times 100,000. So $37,409.13. And that is it for chapter 5.